Hi everybody. In this lesson we're going to go through the definition of congruence of shapes. So with that, in geometry we've used this word congruent before, and there's a special symbol that we use, which is this. It's an equal sign with this little mark above it. So what that really translates to is same size and shape. So for congruence, our definition, we want to say it's the same size, same shape. Now, the good thing about this is the way that a shape is turned doesn't really matter. So if you look here, these are kind of like mirror images of each other. So the fact that they're in different directions doesn't matter. That's still good in terms of congruence. But what we don't want to call congruence is things that look similar, like these two, but they're different sizes. That's actually what we would call similar. And if they're completely different looking shapes like this, then we don't call them anything. They're just two different shapes. So the main thing for today is we're going to talk about what congruence is and how we read it and why it might be helpful for us. So for example, a congruent statement are statements that classify shapes in the correct order. So you can see that there's two triangles here, triangle ABC right here, and triangle FED. Now, even though these triangles are pretty clearly the same, we want to make sure that we're being very specific about how we order the letters. This is the key part of this lesson. So in this first triangle, you see how A has the one arc like that? F has the one arc. In this triangle on the left, B has the double arc, E has the double arc, and then finally C has the triple arc, which means D has the triple arc. So when we talk about the shapes, A and F must be the same, B and E must be the same, C and D must be the same. So in terms of how we want to say it is we're going to say triangle, which is this little symbol in geometry. ABC is congruent to triangle, and this is why this is important. If I go A to B to C, I need to follow the angles that match it as well. So F to E to D. Alphabetical order doesn't matter. The placement of the correct angles is what is the main important part here. Okay? So let's do a little bit of practice here. And you'll see that in this shape, there are two congruent shapes. And you can see right here that angle A has that 90 degree, so I'm going to circle it. And I'm going to look for the other angle that has the 90 degree. So in terms of a congruent angle, we can say angle A is congruent to angle F. And you might not be exactly sure which one comes next. So two strategies. First, look for the double arc. So C and H, that's another set of congruent angles. The other way I tend to do it is if I started at A and I go up the 1 dash line like that, that would be the same as me starting at F and going up the 1 dash line like that. So you can see that we still end up at the same destination. So we can say that angle C is congruent to angle H. And then finally, likewise, angle G must be congruent to angle B. Now, the only other thing with this is, if we're talking about sides, again, we want to be in the correct order. So let's say AC, this side right here, side AC. That needs to be congruent to the correct letters. Again, I started at A first, then C second. So I need to look at this diagram and figure out F has to be the start, H needs to be the stop. So it goes F to H. What's kind of helpful is if you can do the angles first, you can see that A and F lined up first to first, and C to H line up second to second. So without even looking at the diagram, if I said C to B is congruent to what, just using the angles below basically tell me exactly what I want. C has to be congruent to H, and B needs to be congruent to G, which means the statement should be in the same order, H to G, like that. So whenever we have these congruent statements, we basically are looking for the order to tell us what needs to line up, and it kind of does the work for us. Now here's a way that we can use it. So these two shapes are congruent, So I'll say shape QRST, that's this one, is congruent to WXYZ. That's this one. So you can see right off the bat that based on the order that Q and W are the same position. So this equation, 5x plus 5, has to be the same as 65 degrees. And because of that, I can set up an equation to solve for the x in the shape. Subtract 5 on both sides, divide by 5, I get x would be 12. Likewise, I have this little equation here, y minus x. That's in between the angles of x to w. So if I'm not sure, I can look at my statement. X to w are the middle two letters, which means it has to line up. W to x. W to x are the first two letters. That has to line up with the first two letters of this one, Q to R. So now that I can see it, I have a number that I can set equal. So I know y minus x needs to be 6. And from what we solved in the first equation, I have a way to replace the x with 12. So y minus 12 equals 6. And by adding 12 to both sides, I get that y would also have to be 18. So if you notice what I'm really doing, I'm not really making a guess. I'm using the information that was provided from stuff that I see in the diagram to say that I know these sides have to be equal and not just saying these look like they should be. I'm using the information because the information given would always be correct. So let's just do a couple of quick little trials here. So if in this statement, it's a four-sided shape, so it's not a triangle, I want you to try and see if you can figure this out. F to G would be congruent to what two letters? And G to F would have to be congruent to what two letters? So why don't you pause it, take a second, and try it. So I'm hoping you got a chance to try it. So again, F to G is S to T. So it has to be in that order. Likewise, J to F. Now notice how it's at the end to the beginning. I'm going to do the same thing. End to the beginning is V to S. So you don't need to do the work when you're reading it correctly. Likewise, if I wanted to say any of the congruent angles, angle F has to be congruent to angle S. Angle G has to be congruent to angle T. And I'm not even using the diagram to make this conclusion because all I need to do is make sure I have my letters lined up here. So that's all this really turns into. On the back, I'm just going to do one or two of these examples, and then there's some problems that I want you to try in the class, so either in Delta Math or on probably some sort of maze worksheet type of a thing. So the one other thing that we can talk about here is what we call the third angle theorem in a triangle. And basically, in any kind of triangle, if two of the angles that we know line up, then so are the third. So then the third angle must be equal. And in all honesty, that should feel kind of obvious, right? So here's a diagram. A to B, these are both equal. E to D are also both equal. So what conclusion should we be able to make about these two? Well, they must be equal. And the reason for that is because we know that angle AB and C together, if I add those up, that should equal 180. We also know that if I did D plus E plus F, that should also equal 180. But the thing is, these two sets of numbers are the same. So if I'm taking the same number and I'm adding C or F and I still end up with the same number, that kind of has to mean that they must be equal as well. So if I said to you something like, okay, let's take 5, and I'm going to add some mystery number to it, and that's 6, there's only one possibility, right? Whether I put a question mark there or I put a variable there, both of these, because it's the same exact equation, the same exact statement, and they're just replaced, that means they have to be equal to the same thing in this case, which is 1. right? So the idea is in triangles, if all the angles line up except for one, we also must know that that angle has to line up just in order to make it a triangle. So let's look at just this example here for 5, and then that'll be it for the video. So in this diagram, we know that 71 is angle B. They tell us that angle D and angle A are the same. Now, we don't know how much they are, but that's our question. We need to find the value of angle D. So remember, in a triangle, if I know 2 of the angles, I can just subtract from 180. So let's use the fact that these angles are crossing here. So if you forget what this is called, this is what we call vertical angles. And if you remember, vertical angles are equal on opposite sides. So that's 47. And now all of a sudden, if you notice, I have 2 of the 3 angles in that triangle. So to get angle A, I do 180 minus the 71 minus the 47. And so when I do that, I get, I'm pretty sure that's going to get me 52. Okay. So what that means is if A is that value, then D must also be that value because we said at the beginning of the problem that they are the same. So we know that these 2 triangles must be the same. All right. Oh, actually, I think it's 62. I apologize. So I hope that was helpful. There's some problems I want you to try, so please feel free to try those and let me know if you have any questions. Thanks. I'll see you in the next one.